Okay, today we're going to start our Unit 4 unit notes. So Unit 4 kind of takes us in a different direction. We're going to start graphing now. So this unit and our next unit will just be graphing. This unit we're going to do linear, and then the next unit we're going to do quadratic. So our first thing we're going to cover in Unit 1 is we're going to talk about finding slope. So we're going to do it from different methods. Today we're going to do finding slope from just a table. So to kind of start it off, we're going to kind of think about going back to our sequences, what type of sequence it is and what type of function it's going to be. So whenever we're determining our sequence, we have to look at our y values. So we go from 15 to 12 to 9 to 6. So we're subtracting 3 each time. So if you remember, if you're subtracting, it's arithmetic. Or if it's arithmetic, our function is linear. And on this one, our common difference was -3 because we were subtracting. So let's go to the other one. We go from 2 to 6 to 18 to 54. So from 2 to 6, it looks like we're multiplying by 3 each time. So remember, if we're multiplying, it's geometric. Our function type is exponential. And we have a ratio, which is 3. So this unit, we're actually not even going to be looking at geometric anymore. We're done with that. We're done with that until next year. We will start looking at linear. So knowing these differences on our table is going to be super important for us. So what is a linear function? So a linear function has a constant rate of change. What that means is if you guys look back at our sequences, know how we were going up or down by the same amount each time? That is making for a constant rate of change. We're going to call it a slope. But you're like, Mrs. Gilbert, exponential did too. But exponential multiplied. Multiplying and adding are totally different. So with our slope was called rate of change. Slope can have actually a couple different meanings, but another one, which we're going to kind of start talking about also, is rise over run. That is how we find our slope. Or we could call it our change in y over our change in x. Triangle means change. So let's go down to our first example. First one, we have -2, 6, -1, 4, 0, 2, 1, 0, and -2. So to find our slope, this is our slope. Our m is the same as slope. Why it's m, I'm not exactly sure. But the abbreviation for slope is m, and then we have our change of y over change of x. So our change in y, what are we going up or down by each time? So from 6 to 4, going down by 2. From 4 to 2, I'm going down by 2. On the other side, I'm going up by 1 each time. So whenever I'm finding my change, I want to find the two that are on the same line. I don't want to do different ones. So my change of y is -2. And then my change of x is a +1. So this means my slope is going to be -2. Now, what I want to do is I want to graph this on the line. So we're going to graph it using our table. So our first point we have is -2, 6. So go over to -2, up to 6. Our next one is -1, 4. Then we have 0, 2, 1, 0, and 2, -2. So if you can see, this makes a straight line, and that's what we want to do each time. So our slope is -2, and we can see it's a negative slope because as we go from left to right, our line is going down. And then our y-intercept, where does it cross the y-axis? That's going to be at 0, 2. And you can also look at that on the table because at 0, 2, wherever your x value is 0, that's where your y-intercept is. Make sure you write your y-intercept as an ordered pair. Okay, let's go to the next one. So let's find our slope again. So let's find our difference. So from -4 to -1, going up 3. From -1 to 2, I'm going up 3 again. And I'm just going to do those first two. On this side, I'm going up by 1. So I'm going to pick 2. I change a y as 3. I change an x as 1. So 3 divided by 1 is 3. So that is my slope. My y-intercept, if you can find it from the graph, that'd be great. It's where your x value is 0. So 0, 2 is our y-intercept. Now we're also going to graph these points using our table. So -2, -4. -1, -1. 0, 2. 1, 5. 2, 8 is going to be off of our graph, so we're not going to graph it. We already have 4 points on here, so we should be good anyways. Okay, so then you draw your line. Make sure you have arrows on the end of your line. Ooh, I cannot draw a straight line right now, you guys. Okay, there you go. So if you look at it, confirm, is our y-intercept 2? Yes, it crosses the y-axis at 3, 2. Okay, let's go on to the back page. So the back page, we have 3, 4, and 5. So we have 3 more examples. So these tables, I want you to tell you what is different. If you look, our x values are no longer going up by 1. They're going up by 2. So we're going to have to take that into account whenever we are finding our slope from the table. So from 6 to 4, we're going down by 2, and then we go down by 2 again. Our x's, we're going up by 2. So we're going to have to take one of these values and put them in our equation. So we're going to have our y, which is -2 over 2. This is going to give us a slope of -1. And then our y-intercept, it is on here where our x value is 0 at 0, 4. But we can also graph it on our graph and identify it that way too. So we have -2, 6, 0, 4, 2, 2, oh, I graphed that one wrong. 2, 2, 3, 1, and 4, 0. So if you notice, these first couple points, so these first, I can't really do it without my cursor. These first couple points are a little bit different. So we have to think about, okay, but why? Well, it's still having the same slope. They're just going down by a difference. So there's still going to be points in between those. Then we graph our line. Let's see if I can actually draw a straight line to it this time. Make sure you draw arrows on the end again. Okay, next one. Let's find our change in our y's. So we're going up by 2, and then we go up by 1. This one we go up by 4, and then we go up by 2. So it does not matter whether I use 1 over 2 or if I use 2 over 4. You're going to get the same answer. Let's do 2 over 4 because it's the same one. This would reduce to 1/2. Make sure you reduce if it can reduce. Then our y-intercept is 0, -2. And then we can graph these. So -4, -4. 0, -2. 2, -1. 4, 0, and 6, 1. And then I can draw my line. So sometimes you might not have a point every single spot, but you will have them pretty close. Okay, next problem. So this one we got to kind of fill it in. So we know that between 0 and 2, we should have a 1. And we're just going to put a -1 right here. So let's try to figure out from 2 to 4, I'm going up by 2. From 4 to 10, I'm going up by 6. So this one, I'm only going up by 1, though. So what's half of going up by 6? It's going up by 3. So I'd have 1 and -5. So I'm going to use this 6 and 2. For my slopes, I'm going to have 6 over 2, which equals 3. And then this one, my y-intercept was 0, negative 2. Okay, let's graph these points. Negative 1, negative 5. 0, negative 2. 1, 1. 2, 4. And then 4, 10, we're not going to be able to get on our graph, so we're just not going to graph that one. Because normally if you guys have at least 3 points on your graph, I will be okay with it. That goes straight up. Okay, that was our last example, so you guys can get started on your homework. But what we are going to, so today we talked about finding slope from a table and finding the y-intercept. Make sure you understand how to graph from a table. Tomorrow we are going to try to find how we find slope from a graph. So what you're going to do is see these, you have 2 points on here. This is where we take into account rise over run. So we're going to talk about that more tomorrow. If you guys have any questions, please let me know.